Today we'll discuss about the colloids. As we know that a solution is of three types. First one, your true solution, and second one, colloids. Third one, suspension. So these classifications of a solution into three types is based on the size of the solute. Now, in a colloid, as in our class 9 we have discussed that the size is exactly 10 to the power minus 9 meter, then it comes to colloid. If the size is less than 10 to the power minus 9, then it is called as a true solution. Whereas if the size is greater than 10 to the power minus 9, then it is called as a suspension. So when we pass a beam of light to the true solution, the beam of the light easily pass through the solutions. Whereas in case of colloid, the beam of the light becomes scattered. That is why we can easily visible the beam of light. The solute present in the colloids can be visible by your naked eye, same like your suspension. But the solute in case of true solution cannot be visible by our naked eye. So we can say that a colloid is a heterogeneous system in which one substance dispersed, that is dispersed phase, as very fine particles of another substance called dispersion medium. So as in a colloid we have two components, one is dispersed phase, another one is dispersion medium, and the substance which lies in the colloidal size, that is we call as a dispersed phase, whereas the colloidal materials are spread, that substances are called as a dispersion medium. Suppose if we have taken the starch solution in water, so water is a dispersion medium and starch is in the form of colloid, and this is a dispersion phase. So your starch is a phase and water is a medium here in this case. So like this we have. So is the essential difference between a solution and a colloid is that the particle size. While in a solution the constituent particles are ions or small molecules, in a colloid the dispersed phase may consist of particles of a single macromolecules. That means the in case of solution the constituent particles may be ions or may be small molecules, whereas in case of colloid the constituent particle is a group of atoms or ions or molecule. This is what the difference between true solution and the colloidal solution. Colloidal particles are larger than simple molecules but small enough to remain suspended. The range of diameter is 1 to 1000 nanometer, that is 10 to the power minus 9 to 10 to the power minus 6 meter. Okay, then it is called as a colloids. Colloidal particles have an enormous surface area per unit mass as a result of their smaller size. So this is what about the introduction of colloid. Now we will go to the classification of colloids. Colloids are classified on the basis of the following criteria. Number one, physical state of dispersed phase or dispersion medium. And number two, nature of the interaction between the dispersed phase and dispersion medium. Third point is type of the particles of the dispersed phases. So like this, based on three criteria we can classify a colloids. Now let us see classification based on the physical state of dispersed phase and the dispersion medium. So depending upon the whether the dispersed phase and dispersion mediums are solid, liquid, gases, 8 types of colloidal systems are possible. A gas mixed with another gas form a homogeneous mixture, and hence it is not a colloidal system. So Many familiar commercial products and natural objects are colloids. So let us see some types which you have. If dispersed phase is solid and medium is solid, then the type of the colloid is solid sol. Okay, both the medium and the phases are solid, then we call as a solid sol. So some example of this is one of colored glasses and the gemstone is of the example of solid sol. Like this one, if the phases is solid and medium is liquid, then we call as a sol, SOL. So examples are pen and cell fluids. Like this one, if phase is solid and medium is gas, we call as a aerosol. Okay, so aerosol means example is your smoke and dust. Smoke and dust are of aerosols only. Like this one, liquid is a phase and solid is a medium, then you get gel. Say in your Colgate gel also. Okay, so example is cheese or jellies. If both the phases and mediums is liquid, then we call as a emulsion. So simple example of emulsion is oil and water. Okay, so like this one, milk, hair cream, butter are the examples of emulsion. If phases is liquid and medium is gas, then the type of the colloid is called as a aerosol. Examples are fog, mist, cloud, and insecticide sprays. Like this one, if the phases is gas and medium is solid, then we call as a solid sol. Example of solid sol is foam rubber. Like this one, if dispersed phases is a gas and medium is a liquid, then we call as a foam. So we have foam in the flotation, like this. This is one example of that. And like this, we have whipped cream and soap leathers are belongs to this category. Now let us see. So, let us see classification based on nature of interactions between the dispersed phase and dispersed medium. Now, based on this one, we have two types. One is lyophilic, another one is lyophobic. So, lyophilic means solvent attracting, and lyophobic means solvent repelling. Now, as we have already discussed that there are two types based on the force of attraction between the medium and the phases. So, first one, what I say, your lyophilic colloid. Lyophilic colloid means what now? Solvent attracting colloid. That means easily it can make the colloidal particles with the simple intermixing with the phases along with the medium. Then it is called as a lyophilic colloids. Okay. The lyophobic colloid means one of solvent repelling colloids. That means here what we have, the colloids cannot be prepared directly by mixing. Okay. So with the medium. Instead, to prepare that colloids, we require some another process. Okay. That means indirect process you require to prepare that one. Then it is called as a lyophobic colloids. So lyophilic colloids are called as reversible sol. If the dispersion medium is separate from the dispersed phase by evaporation, the sol can be reconstituted by simple remixing with the dispersed medium. That means if you remove the phases from the colloid, after then again if you mix the phases again, then it makes a colloid. That is why it is called as a reversible sol. And these lyophilic colloids are quite stable and cannot be easily coagulated. But In case of lyophobic, we call lyophobic colloids as a irreversible salt. Irreversible salt. Why we call lyophobic colloid as an irreversible salt is that these salts are readily precipitate on addition of a small amount of the electrolyte, or you can precipitate out lyophobic colloid by adding electrolyte or by heating or by shaking. That is why they are not stable. Once the precipitate is formed, they cannot go back to the colloid again. That is why it is called as a irreversible salt. Lyophobic salts are stabilizing. Lyophobic salt needed stabilizing agent for the preservation. Means that because of unstable nature, to keep storage, you need some other chemicals. These chemicals are called as a stabilizing agent. So we require a stabilizing agent for storing lyophobic colloid. Generally, we added lyophilic colloid to the lyophobic colloid for storage. If the phases is added in water to make the colloid, that means medium is water, then we call that one as a hydrophilic colloids or hydrophobic colloids. Those colloids in which you can make easily by addition of water is called as a hydrophilic colloid, whereas those colloids which cannot make easily by mixing with water is called as a hydrophobic colloid. So there are two types of colloid. One is hydrophilic, another one is hydrophobic. If the water is used as a medium. So here also same thing. Hydrophilics are reversible salt and hydrophobics are irreversible salt. Hydrophilics are quite stable, whereas hydrophobics are less instability. That means unstable. So this is what about the classification based on interaction between the dispersed phase and the dispersed medium. Again, classification based on type of the particle in the dispersed phase. Now we have three types. Based on this one, we have three types. First one, multimolecular colloid. Second one, macromolecular colloid. Third one, associated colloids. So here multimolecular colloid means small molecules combined together to form the colloids. Then it is called as a multimolecular colloids. The species thus formed by combining smaller substance together to get the colloidal ranges that we call as a multimolecular colloids. Example is gold salt or sulfur salt. They contain thousands of your small sulfur molecules or gold molecules to get the colloidal size. That is why they belongs to multimolecular colloids. Next is macromolecular colloids. Macromolecule in suitable solvent form solutions in which the size of the macromolecule may be in the colloidal range. Such systems are called as a macromolecular colloid. So that means in the macromolecular colloid, the bigger size breaking down into smaller one to get the colloids. Then it is called as a macromolecular colloids. These macromolecular colloids are quite stable and resemble like true solution in many respects. So example of macromolecular colloid is your starch, celluloid, protein, enzymes and others like nylon, polystyrene, synthetic rubbers. These are belongs to macromolecular colloid. Another one is associated colloids. Here we know that at low concentration some substances behave as a normally strong electrolyte, but at a higher concentration it can exhibit in the colloidal system. Then it is called as a associated colloids. So As association means, in an association where many persons are there, like that many small particles together can form this associated colloids. Now, the formation of micelle taking place only above a particular temperature. Say micelle means that groups which you get in the soap molecules, the cultures of soap molecules we call as a micelle. If the soap molecule from micelle, they readily arrange in order to get a particular structure where all the heads are outside, all the heads are inside and all the tails are outside. This cultures is called as a micelle. So this micelle formation take place only in the particular temperature. That temperature we call as a Kraft temperature. Okay, so that is why when we wash the cloth, then we say that clothes should be washed only in lukewarm water. So the cleaning action should be appropriate only in the lukewarm water. And this why? Because it can form more micelles. This micelles can help to clean the dirt. That is why cleaning action is most sufficient or most efficient in case of hot, what means lukewarm water. That is what we have. So above a particular concentration, only this micelle formation take place. This particular concentration is called as a critical micelle concentration. That means it is the concentration of the soap molecule which can form micelles. Less than that concentration, there is no micelles. It will behave as a strong electrolyte. But if the concentration of the soap molecule reaches to that, then we start formation of this micelles. That concentration of the soap molecule is called as a critical micelle concentration. Now, we have, in case of synthetic detergent, we have particular micelles concentration, whereas in case of soap, we have 10 to the power minus 4 to 10 to the power minus 3 moles per liter. This is the critical micelles concentration of your soap. Now, mechanism of micelles formation. Let us see. Mechanism of micelles formation. We will see that one. Now, soap is a sodium or potassium salt of higher fatty acids, as we know that, and it can be represented by RCOO Na plus, RCOO minus and Na plus. Example, we can take it as a sodium stearate, which is the major components of our commonly used soap. When dissolved in water, it dissociates into RCOO minus and Na plus ions. RCOO minus ions consists of two parts, a long hydrocarbon chain R and non-polar tail, which is of hydrophobic in nature. And hydrophobic means water repelling. And a polar group, that is COO minus, is called as a polar ionic head, which is hydrophilic in nature. So as these soap molecules, that means RCOO minus Na plus, when decomposed, we got it two part, one is R, another one is COO minus, where R is called as a tail. Tail is of hydrophobic, that is water repelling part, and COO minus, which is polar end, and we call as a hydrophilic part. So the RCOO minus are therefore the presence of surface with their COO minus group in water, and the hydrocarbon part, that is R, staying away it and remains at the surface. Okay, R is at the surface, whereas COO minus is in the surface of the water, is because CO minus is hydrophilic part and R is hydrophobic path. But at the critical miscellaneous concentration, the anions are pulled into the bulk of a solution to get an aggregate form, which is in spherical shape, with their hydrocarbon chain pointing towards the center of the sphere, with COO minus part remaining outward. So, in a miscellaneous concentration, R should be inside and CO minus should be outside. So the cursor makes a sphere. This arrangement is called as a ionic miscellaneous. So the miscellaneous may contain many many as 100 of such ions. Now let us see what is the difference between soap and detergent. Soaps, we can say that sodium or potassium salt of fatty acids, long chain fatty acids, that makes a soap. Whereas in case of detergent, it is a sodium or potassium salt of sulfonic acid. Salt of sulfonic acid. Example of one common example of your detergent is sodium lauryl sulfate. There is CH3, CH2, 11 times SO4 minus and Na plus. The polar group, that is sulfate ions, along with the long hydrocarbon chain. Hence, here also the mechanism of miscellany formation are same as that of the soap. Now let us see about the cleaning action of a soap. The cleaning action of a soap is due to their soap molecules form the miscellaneous around the oil droplets in such a way that hydrophobic part, that is R, of the stearate ions in the oil droplet, and the hydrophilic part, that is your COO minus part, projects outward of the grease droplets like the bristles. Since the polar group can interact with the water, and the oil droplets surrounded by the stearate ion is now pulled in the water and removed from the dirty surface. Thus, soap help in emulsification and washing away of oil and fats. The negative charge sit the negative charge sit around the globules, prevent them from coming together and forming aggregates. So like this, it will, your body means that your clothes will be cleaned by the soap molecules.